Hey, for Thursday's science, this is where we stopped yesterday. And once I figure out the whole Google Meet record thing, I can do it on my screen. Mr. Keen's trying to teach me, but I'm a slow learner. So I'm just going to keep doing it this way for today. And hopefully you got your science notes out, ready to go. We're talking about using weather maps. Most maps agree on symbols. There can be some variations, but you see where the H is for a high, the red L is for a low, where the different fronts are and things like that. There's a better look at things. The blue you can see as a cold front, and you can see the direction it's going. So this will be a cold front going that way with a high pressure behind it. This would be a warm pushing that way, so a little bit of push back. A little warm coming up this way, cold coming down this way, and along those fronts is where you see the weather, if there is any. Moving on, we're going to talk about the fun stuff, what happens during severe weather. So this is lesson 5, Roman numeral 5, lesson 5, what happens during severe weather. Okay, first of all, the types of storms that we look at are thunderstorms. And in thunderstorms, like mentioned before, when you have a cold air mass and it meets a warm air mass, like in this illustration here, the cold always wins. It's just thicker and heavier. And if it moves in very quickly, it forces that warm, moist air up quickly. And then that warm, moist air, those molecules start slowing down, and then the water molecules in there condense, form droplets, and then rain. And then if it goes up really fast, that's where you get the quick up, and you have to replace it with other air, so cold air dropping down, and that's where the friction happens. You can see in this one here, you have downdrafts, you have warm updrafts, and just like when you pull the stopper out in a bathtub, when the water starts dropping down, starts cycling down, same thing here, except it's draining up, we would say, and it starts to cycle. Okay, this is a perfect huge cumulonimbus cloud that shows your heavy rain, possibly hail. So cold air mass meets warm, warm rises quickly, produces tall clouds, collisions between ice crystals and water droplets, rain pulls cold air down with it, called downdrafts, warm air produces updrafts. When we get a tornado, that's where that swirling updraft starts happening. And then when you start getting those crossing and the static electricity, we get a buildup of electrons. And in the air, or in everything right now, this screen, if I touch it, I don't get a shock. But it does have electrons and protons in it. The thing is it has an equal amount of both, so it's neutral. Let's say there's 10 protons and 10 electrons here on that screen, so I don't get a shock. But if you slough your feet across carpet and then touch a metal doorknob, what you've done when you're sloughing is you create static electricity where you have a buildup of electrons, and there's a gap between the electrons and the protons, and the electrons want to jump that gap and be neutral again, okay? So in this case, you have a buildup of electrons here, protons up here, so they can jump up in the cloud here, or if there's protons on the ground, they'll jump down to the ground. Most of the lightning happens up in the air. We see strikes every once in a while hit the ground, but most of them happen up here as they cross a gap. Because when that static happens due to that rubbing of molecules going up and molecules going down, you have a buildup of electrons, buildup of protons, and then the buildup becomes so great that it can jump that gap. And that's what it says here. Moving air causes static electricity. Electrons and protons are separated and build up. Once they jump the gap between them, lightning occurs. That's an electron charge. The streak are electrons moving. The sound is rapidly heated air as it expands, causing thunder. Now, when I was a little kid, when I'd see the lightning, I was told, hey, count every second is a mile. But actually, it's not that way. Lightning makes thunder, flash is seen instantly. Thunder travels a mile in 5 seconds, so actually thunder is quite slow in comparison. Light travels around the entire planet like 7.5 times a second. But it takes 5 seconds to make thunder go a mile. So if you see the lightning and you go 1, 2, 3, 4, 5, and then you hear the boom, it's only a mile away. Next, tornadoes, more specifically, are rotating columns of air. They're very violent. They have a funnel shape with a cloud, very extremely strong winds, and the stronger they are, the more they rise on this Fujita scale. The Fujita scale is the original scale, an F0 to an F5, but they've changed it since 2007 to call it the enhanced Fujita scale. And they changed the numbers on the winds. But just essentially the faster the wind goes, the more it moves up that Fujita scale, and F5 being the largest and the most destructive. The duration could be minutes, could be hours. Speed could be, oh, we got kilometers here. If you look here, between 65 and 200. The Fujita scale F1 to F5 based on wind speed. Doppler is helpful because, as we mentioned before, with the Doppler radar, Doppler can not just pick up things in the air, but they'll also pick up direction, so they'll be able to see any kind of twisting or spinning, and they can make a determination on if you should seek shelter or not. Now, there's a really cool Make a Tornado video that I'll show you when we get back. But the next time we talk, we'll be talking about hurricanes. I'm going to stop the video now. Hopefully you got enough of the notes from today.